In my opinion, ferrofluids are one of the most visually interesting things that I've ever seen, just because they look so weird. Under normal conditions, it just looks like an oily liquid, but when it's exposed to a magnetic field, it forms these spikes. However, when the magnetic field's taken away, it instantly goes back to being a free-flowing liquid. When I first saw this, I thought it almost looked like magic, but the general idea behind it isn't actually that complicated. It's all based around a magnetic iron compound, which is almost always magnetite. Under normal conditions though, if magnetite were mixed into a solvent, it would very quickly separate out, especially under a magnetic field. So to fix this problem, the magnetite particles are chemically coated with something that allows them to be stably suspended in the solvent. If this is all done properly, the magnetic field won't be able to pull the particles out of solution, but they'll still react to it. And the result of that is this weird magnetic liquid that we call a ferrofluid. Ferrofluids can be used practically in many things like hard drives or speakers, but I feel like most people, including myself, are just interested in playing around with it. The biggest issue though is that it tends to be super expensive. In the US it seems to be a bit cheaper, but in Canada it's usually around $1 a milliliter for small amounts, or around 40 to 50 cents if you buy more than a liter. There are some videos and tutorials out there where people make it from cheap things like printer toner and motor or vegetable oil, but this doesn't make a true ferrofluid. It instead makes something called a magnetoriological fluid, or just an MR fluid for short. It can still be fun to play with, but it's just not the same thing, and it often easily separates from the carrier solvent. So I decided that it would be my responsibility to come up with a cheap and relatively easy way to make a good ferrofluid. I spent several hours online, and I managed to find what seemed like some decent procedures. However, for some reason, they all seemed to be a bit different. So I did my best to just combine all of the info into what I thought would be a good method. However, as you can maybe tell from the title of this video, which is Attempting to Make Ferrofluids, I wasn't exactly successful. It turned out to be way harder than I initially thought, and I'm gonna have to put a lot of practical research into it. What I'm gonna go over in this video is my first major and partially successful run. It's nowhere near a perfect or polished procedure, but I still thought it would be interesting to show you all the problems and where I'm at in the whole thing. In any case, the first step in the prep was to make the magnetite, and to do this, I needed a source of iron 2+ ions, iron 3+ ions, and ammonia. For the iron 2+, I used iron 2 sulfate that I purified from plant fertilizer in a previous video. And for the iron 3+, I used iron 3 chloride, which I also made in an older video. If you're at all interested in seeing how I prepared either of these iron compounds, there are some links in the description. And for the ammonia, I just used 10% ammonia cleaner that I found at my local hardware store. After making the magnetite, the particles needed to be coated with something, and it's pretty typical to use oleic acid. I ended up just buying it from eBay, but in theory, it is possible to make it from olive oil. Okay, so the first thing that I had to do was make a solution of the iron 3+ ions. And to do this, I added 54 grams of iron 3 chloride, also known as ferric chloride, followed by 100 ml of water. Then I turned on the stirring, and I waited for it all to dissolve. After several minutes, pretty much all of it had disappeared, except for a very small amount. These were just some impurities from when I made the ferric chloride, probably some iron oxides, and to get rid of them, I had to filter them off. In the past, I tried just doing a regular gravity filtration, but it didn't seem to work very well. So what I did here instead was a vacuum filtration, where it first went through a coffee filter and then a proper filter paper. Below the filter, I collected the nice and clear solution, and I think it took about 5 or 10 minutes for everything to pass through. When it was done, I took away the filter, and I moved on to making my iron 2+ solution. This time, I used 27.8 grams of iron 2 sulfate, also known as ferrous sulfate, and again, 100 ml of water. I turned on the stirring and it started to dissolve, but there was a slight yellow color to the solution. Ferrous sulfate tends to react with oxygen in the air, and this was probably some sort of oxide that had formed. To deal with this, I just added a few drops of sulfuric acid, and you can see that the color quickly disappeared. After stirring it for a few minutes, everything dissolved, and I moved on to the next step. Into a nice 1 liter beaker, I added the ferric chloride solution that I just made, and I turned on the stirring. Then into this, I poured in the ferrous sulfate solution. There was no reaction going on here, and I now just had a mixed solution of iron 2 plus and iron 3 plus. I let it stir for like 30 seconds, and then I tested the pH. From this, I saw the pH was around 1, which was perfect. If it weren't, I would have had to add some extra sulfuric acid. The next thing I did was position a separatory funnel just above the solution. Then I carefully filled it up with the 10% ammonia cleaner. When I was ready to get the reaction going, I turned the stirring close to maximum and I opened up the separatory funnel. Ammonia is a base, so as it was added, the pH slowly increased. There was initially no reaction though, because everything was still quite acidic. However, when the pH was raised to between 2 and 4, the iron 3 plus ions started reacting with it to make brown ferric hydroxide. And as more ammonia was added, more ferric hydroxide was made, and the mixture got browner and browner. The original dark yellow-brown color of the ferric chloride also slowly disappeared. Then when the pH got to between 7 and 9, the ammonia started reacting with the iron 2 plus ions to make ferrous hydroxide. Very quickly after it formed though, it reacted with the ferric hydroxide to form a mixed iron compound called magnetite. Because this reaction was done slowly, with a weak base, fast stirring, and in dilute conditions, the magnetite particles that formed were extremely small. With this method, it's hard to control the exact particle size, but most of them should be nanoparticles. When it comes to making ferrofluids, it's extremely important to have the magnetite particles as small as possible, and you'll see why in a bit. I had to bring the pH of the mixture up to around 10, but by the time it was nearly full, it wasn't there yet. So I had to temporarily stop things and transfer everything to a larger container. Then I just continued the addition, and I kept checking the pH. It eventually got to the target pH of around 10, so I stopped the addition and I took away the separatory funnel. Then I turned off the stirring and I brought in a really strong magnet to help pull the magnetite out of suspension. When most of it had settled out, I used a beaker to pull out the excess water. I continued doing this until I got to a volume of about 700 ml, and then I transferred it back to a beaker. Just for fun, I brought back my magnet and played around with things a bit. The way that it behaved here was almost like a ferrofluid, but it wasn't because none of the particles were stabilized in any way. This meant that most of the magnetite was easily pulled out of solution, and if I left the magnet there, it eventually would have cleared up. In a proper ferrofluid though, the particles are treated, so even if they're exposed to a strong magnetic field for a long period of time, they never separate. So this treatment step was exactly what I had to do next. I cleaned up the beaker with some water, turned on the stirring, and slowly added 25 milliliters of oleic acid. After it was all added, I increased the stirring a bit more, and I turned on the hot plate. The goal now was to slowly increase the temperature until it got to around 90 C. In the last step, I brought the pH up to around 10, which meant that there was an excess of ammonia. So now, the first reaction that was going on was between the oleic acid and that leftover ammonia. This formed ammonium oleate, which unlike oleic acid, was soluble in water. The polar ends of the ammonium oleate were then adsorbed to the surface of the magnetite nanoparticles. And as the temperature was slowly increased, the ammonium oleate degraded and went back to being oleic acid. At around 80 or 85 C, I started to notice some clumping, and by the time that it got to 90, everything separated out. The reason this happened was because at this point, the particles were covered with enough oleic acid to make them extremely hydrophobic. After it separated, I heated the solution for 10 more minutes, and then I took it off the hot plate. I dumped off all the liquid, and then I added distilled water to wash it. I did my best to break it up, but it was really oily and all stuck together. I also had to reach in and manually pull out my stir bar, and you can see how nice and dirty it was. However, it honestly wasn't very hard to clean, and I just washed it with some kerosene and maybe a bit of acid. When I felt like I had given the particles a decent enough water washing, I put the magnet to the beaker and poured everything off. This water washing process was then repeated 2 more times. When that was done, I then washed it 3 more times with ethanol to get rid of any excess oleic acid. What was weird was after the first and second washing, it gave me a nice separated powder, but after the third one, everything clumped together again. I'm honestly not exactly sure why it did this. In any case, when I was done, it looked like I lost a decent amount of magnetite in the washings, so I put a magnet under it to pull it all out. I let it sit for about 10 minutes, and then I poured off the liquid and saw that there was a decent amount at the bottom. This recovery, along with the main stuff, was then transferred onto 2 small dishes. Both of them were still full of ethanol, so to dry them, I put them in my vacuum desiccator overnight. By the morning, the ethanol was gone, but they were both still a bit oily. I think this might be because I used way too much oleic acid in the coating process, so the washing steps didn't get rid of it all. In any case, to test it, I took a small piece from the main batch and added a minimal amount of kerosene. Kerosine's a very nonpolar solvent, and it'll hopefully be able to interact with the nonpolar oleic acid that I attached to the surface of the magnetite particles. This should allow the normally insoluble magnetite to be dispersed in the solvent almost as though it was being dissolved. However, it technically isn't getting dissolved, and it's more accurate to describe it as a stabilized colloidal suspension. This coating of oleic acid also helps keep the particles separated, and it prevents them from aggregating together. Ideally, the final result will be a stable suspension of magnetite nanoparticles that can interact with a magnetic field, but still stay in solution. When I felt that it was ready, I went ahead and tested it, and it kind of worked, but the quality was really bad. To be fair though, it did still kind of work, but it didn't look like it was completely liquid, and it also didn't spike at all. I then whipped up a much bigger batch, and it was pretty clear that this was a terrible ferrofluid. However, on the bright side, I thought that it still kind of looked cool. In a good and proper ferrofluid, the spikes look pretty soft, but here, they were really sharp. And the reason for this was that most of my particles were unfortunately aggregating and getting pulled out of solution. I'm not exactly sure why this happened, but there were only 2 real variables to consider. The magnetite particles were either too big, not coated with enough oleic acid, or it was a combination of the 2. After seeing this, I kind of just assumed that my whole process was a total failure. However, before just scrapping what I had and moving on, I went online to try to find a way to salvage it. And in my research, I ended up finding a YouTube video where a guy demonstrated the most high-quality homemade ferrofluid that I had ever seen. He didn't post a proper tutorial or video about how he did it, but he did reply in the comments. I read through all the comments that he made on all 7 of his ferrofluid videos, and they were honestly really helpful. In my opinion, his most important point was that in making ferrofluids, there are 2 major parts. The first is making the coated nanoparticles like you already saw, and the second is purification. The general idea that I got was that it didn't matter how good my process was to make them, I still had to purify out the ones that were too big, or the ones that weren't coated properly. He only gave some really basic details about the purification, but it seemed simple enough, so I decided to try it out. Now going back to what I recovered, I initially planned to test these 2 samples separately. However, after seeing the poor results that I got, I didn't really think this was worth it, and I just decided to combine them. I didn't just straight up mix one into the other though, and I decided to spread them out as evenly as possible across the 2 dishes. Then I took the one on the right and tried to purify it. The reason I was only doing it with half the amount instead of the full thing was that I wanted just to make sure I had a backup in case I messed up. Once I got it all transferred to a beaker, I started adding some kerosene. Then I mixed it all around, and I tried to get it to dissolve. I kept adding more kerosene when I felt I needed it, but in general, the goal was to use as little as possible. After stirring for another few minutes, it really didn't look like this beaker was gonna be big enough. So I transferred it all to a larger one, and I washed the beaker a few times with a small amount of kerosene. Eventually, something like 95% of it had dissolved, but I used way more kerosene than I expected. There was also some insoluble junk at the bottom, so I poured everything off from this beaker into a new one. Particles that are properly sized and coated dissolve really easily into kerosene, and you don't need much of it at all. So I think the major reason why I had to use so much kerosene here was just that my particles were really bad quality. Just for fun, I tested things out with my magnet, and you can see that immediately a bunch of solids separated out. After seeing this, I realized that I probably could have just used a lot less kerosene and dumped off most of the junk. The good particles should have all just stayed in solution, and I probably could have gotten away using a lot less kerosene. In any case, for the next step, I still had to use the magnet, but this time the beaker was just placed on top of it. It was then left to sit here undisturbed for about 24 hours. The basic idea here was that all the crappy particles would get pulled towards the magnet, but all the good ones would easily stay in solution. So I came back a day later and I poured off the liquid. And at the bottom of the beaker, I was left with all my crappy magnetite particles. Like before, they were still fun to play with, but they weren't going to be useful for making any kind of ferrofluid. All the good quality particles were still in the kerosene, and to get them out, I had to knock down their solubility. And to do this, it was quite simple, and I just had to add about twice the volume of acetone. Unfortunately though, since I used way too much kerosene in the previous step, it's now carrying over and making me use a lot more acetone. In future runs, I'm definitely going to keep the amount of kerosene to a minimum, and instead of using around 150 mils, I probably could have gotten away with something like 10. Anyway, with all the acetone added, I put it on a magnet, and I let it sit there for a couple minutes. I then poured off all the solvent, and at the bottom, I was left with a brown paste. With the help of a bit of acetone, I transferred it all to a small dish. Then I used the acetone that was here to mix things around and to wash the particles a bit more. To separate it from the solvent, I just did the same thing as other runs, and I put it back on the magnet. This time though, things seemed to be quite different. The particles very quickly separated from solution, and with very little effort, everything cleared up. There was no apparent sign of anything aggregating, and it appeared to be a very nice and finely divided powder. Just for good measure, I washed it a couple more times with acetone, and then with the help of the magnet, I dumped off the solvent. I was left with a paste which now needed to be dried, so I spread it out with a glass rod. Then I set up a small fan to blow air over it, and to get rid of the acetone. As it dried, I occasionally mixed things around, and I think this whole process took something like 20 or 30 minutes. When it got to this point, it was pretty much done, but just to really dry it up, I put it in an oven at around 40°C for another hour. And after this, I was left with a really nice and crispy black powder. I was pretty happy that things seemed to be working out, but the yield here was still really miserable. The mass of the powder here was about 0.62 grams, where the theoretical yield for the half batch was at least around 11.6. This meant that my percent yield was probably lower than 5%, which is very far from ideal. In any case, before continuing on with any conclusions, I first had to see if this powder actually worked. So I dumped it all into a beaker, and then I slowly added a minimal amount of kerosene. After mixing it thoroughly and carefully adding extra kerosene drop by drop, eventually everything dissolved. Then to test it, I poured it onto a watch glass which was sitting on top of my magnet. And almost immediately, the result was clearly better than the last time. However, the first thing that I noticed was that it still wasn't doing any spiking. I tried moving it around and playing with its spacing from the magnet, but I never got it to work. At first, I thought that maybe my volume was just too low, so I tested it with an even smaller amount of the commercial fluid, and it was still able to easily spike. One other possibility was that maybe it was just too dilute. So I again got some of the commercial stuff, and then I added some kerosene. With every drop, the spikes slowly disappeared, and I was eventually left with something that looked very similar to the stuff that I made. Based on this, I think it is pretty likely that I just used too much solvent. When I was done, I shot some acetone onto the dish to wash it, but what I noticed was that all the precipitate was black. If you recall from earlier though, when I did this with my stuff, it ended up being brown. At the time, I thought it was just because of the oleic acid coating or something, but this clearly isn't the case. The coated magnetite, as far as I can tell, is just as black as the regular stuff. I'm thinking now that it's very likely that the brown color was actually from a different iron compound. And the major problem with that is that most other iron compounds aren't nearly as magnetic as magnetite. So I think my fluid wasn't able to spike because not only was it too dilute, a lot of the particles probably just weren't magnetic enough. I think the reason for this comes down to what I used to make the magnetite. The ratio of the iron 2 to iron 3 has to be as close to 2 to 1 as possible, and the chemicals also have to be pretty pure, or else other iron compounds can start being made. I think the quality of my iron supplies were good enough for other applications, but I just don't think it really cut it here. So the next time that I try this, I'm not going to be using any of my homemade iron compounds. Instead, I'm just going to directly buy a pre-made solution of iron 3 chloride that's normally used to etch circuit boards. From this, I can also make my iron too by just dumping a whole bunch of nails into a portion of it. My coating process in this video was also kind of a bit sloppy, and I plan to change a few things about it. In any case, this is an active project that I'm working on, and I hope to get decent results pretty soon. And when I do, I'll actually try to edit it in a reasonable amount of time and get it out to you guys. As usual, a big thanks goes out to all my supporters on Patreon. Everyone who supports me can see my videos at least 24 hours before I post them to YouTube. Also, everyone on Patreon can directly message me, and if you support me with $5 or more, you'll get your name at the end like you see here.